My guest is robdelaet, a Dutch entrepreneur and climate strategist who also owns a valley in the Brazilian rainforest. He is author with Peter Bunyard of a new book, Cooling Climate Chaos, a proposal to cool the planet within 20 years. Rob, it is absolutely outrageous that you propose to cool the planet in 20 years. What is the deal?
It's actually pretty simple, Hart. Um, the current climate dialogue, especially in the IPCC, basically focuses on carbon, CO2. Now, of course, that's important. It does heat up the planet. But what is completely left out of the story is that there's another mechanism that cools the planet, and that is water, the water cycle that basically it rains down on plants, makes them grow, and then it's sucked up by the plants again with evapotranspiration going into the air, making clouds, making rain. And this is basically a heat pump, an air conditioning system that has been perfected by nature. And we have been removing so much living ecosystems just since we started we have this beginning point of the climate crisis in 1818. We have been removing an area the size of the United States of forests around the world, and especially the last few decades in the tropical rainforests, basically degrading this cooling function of the biosphere. So what you do is you regenerate the biosphere in as many places as you can, and especially in the tropics, because there the effect is goes fastest, both degenerative and regenerative, because most sunlight comes in. So there, most sun
Let,
energy
let,
needs
let
to be
me let me
processed.
Yeah, let me interrupt just a minute because you're
Sure.
proposing a fundamentally different cooling mechanism, and you're saying that we've removed biomass. You're saying that the biosphere has the capability of cooling, and that part of
Yes.
that is through water cycles.
Yeah, that's correct. Yes.
So how does that? Okay, let me share with you my understanding of some of how that works and let you respond. So, for one thing, water is a buffer. It keeps things from getting too hot and too cold. But water evaporates, and trees and plants cause water to evaporate. And when water evaporates, it has a cooling effect. And that
Yeah.
cooling effect is not small, it's very big, it's dramatic. So you're saying that this cooling effect of evaporating water has the potential for cooling our climate in 20 years.
Well, but it's in phases. So the
Okay.
first one we understand. So if you sit under a tree, it's not just the shade that cools it, but it's also the water that is being evaporated, that goes from liquid into vapor, that draws energy, heat from that area, and basically it goes up in the atmosphere. Once in the atmosphere, there's a second element that plants and especially trees add to it, which are bioaerosols, small particles that also give the possibility for that water vapor to recondense and make clouds. So first the heat is taken up from the forest floor or the surface of the earth, brought up to that level at the cloud, and at the cloud level a lot of things happen at the same time, but basically the water recondenses, makes clouds. The first thing that it does with that is basically form an umbrella against the sunlight. And especially in the
Mhm.
tropical rainforest, you see that in the afternoon you see the clouds form, and then that albedo becomes stronger, and so the sunlight is being kept out. That's one cooling. The second thing that happens is actually the moment that the water goes back from vapor to liquid, all the energy that was taken out is actually radiated out in a certain frequency. And that frequency happens to be mostly in what they call an atmospheric window, a frequency that does not get picked up by the greenhouse gases, CO2 or water vapor. So a lot of it radiates out straight into space. So that's the second way in which the water cycle cools very quickly. And then a third one that happens is if you have large forests, because of the implosion of that gas into liquid, it diminishes more than 1,000-fold, and that creates an underpressure, and that underpressure basically creates both an updraft and a side draft. And if you have coastal forests, they basically pull in, because of this underpressure, they pull in moisture from the oceans. So you get basically a system that rains out on itself, because the clouds then rain out again, get sucked up, and this process goes on. And in large forests, that sideway movement, which is called the biotic pump, is going is re-raining on itself. So in the Amazon, an average drop falls about 7 times before it leaves on mostly on the southeast side, also on other sides. So nature has made marvelous ways in cooling and rehydrating all the time the land masses. And we have disturbed that process completely, and that is bringing a lot of heat into the land, because it doesn't get exported back out.
How have we disturbed that process?
Well, by large, land use change mainly because of agriculture. But of course also because we have more and more infrastructure, cities, etc. Apart from that, also because we have disturbed the biology of the oceans. Let's not forget that 71% of the Earth's surface, and there the total biology of the seas basically also are part of these cooling processes in a different way. But if you disturb it there, you get the same problem, especially in less cloud formation. And I saw a calculation not long ago, and I think that if we would tomorrow increase cloud cover globally by 1.5%, the Earth wouldn't warm up anymore, because that would be such an umbrella and taking the sunlight back into space. So there's many ways in which the biosphere creates the mechanisms to keep the planet at the temperatures that are good for life. And we have disturbed that on land by removing huge amounts of vegetation, especially forest, and on the seas by basically killing a lot of the life that is there in multiple ways: pollution, runoff, over catching too much fish, etc.
Right. You have said that if you see the Earth as a supra-organism that regulates its own processes to create homeostasis, including a balanced temperature, then you start to look at the process differently. So how would it change things if we saw the Earth as a supra-organism?
Well, you can just start to compare it to your body. You know that we have glands to when it's hot, we start to transpire water, for instance. We have our blood circulations, and that produces basically us as living being, talking, interconnecting, etc. If you look at the whole planet, then you see that these processes also regulate the conditions for life to thrive. And we're talking about ocean currents, we're talking about the atmosphere. The atmosphere, basically, we are taught that the atmosphere is there, it's a given. But actually, the atmosphere is a product of the biosphere and is constantly renewed as a gaseous skin to protect us from the cold and the heat from the atmosphere. If you compare us to the moon, on the dark side of the moon, it can be more than I'm metric 100 degrees centigrade below zero, and on the other side, I'm more than 100 degrees above zero. Temperatures that are absolutely not conducive to life.
Mm.
While here, we have a very pleasant average 16, now going into 17 degrees centigrade globally, with the largest fluctuations, of course, in the Antarctic in downturns. But we keep these processes at a level that can sustain life, and that is basically a process by the biosphere all the time, interacting with the atmosphere and water to take that heat and basically throw it out back into space. While meanwhile, there are nutrient flows that sustain the planet. The CO2 is captured and made into living beings, and that's a beautiful process of a living being. And once you see like that, you can always say, if you go to any place, why is this ecosystem here in that form? What is it trying to solve? And then you come into the area of biomimicry. You say, basically, if we mimic the processes that life has been working on for hundreds of millions of years and got pretty good at it, then we probably can improve the situation on the ground at that place um, through this, mimicking.
Yeah. So you're saying that life, I like saying that life creates the conditions for life. We have a livable we have a livable climate because we have a living planet. We have a livable planet because we have a living planet. So as compared with the moon or Mars or Venus, you're going to have extreme temperatures in those places, whereas Earth, the living systems, the living processes, the living species tend to create conditions that are favorable to themselves. It's very analogous to natural selection. You tend to create the conditions that are going to be favorable for the perpetuation of your genes, and that includes you're going to nurture the ecosystem that you depend on.
Exactly. But of course, in the traditional biology, we always focus on individual species, while what we in this way of thinking do is see especially the interrelation between species. But we both know now that a teaspoon full of healthy soil has a billion critters in it that all work together. And this planet is teeming with life that sustains other forms of life as well, and they're all interacting. And once we get that to understand that this interaction, this interbeing, is crucial to the maintenance of life, then you start looking at it as a whole system.
So, as opposed to what? When you read the papers or you see reports coming from the media, what are they saying about what drives and regulates our climate?
CO2.
You could stop there.
Almost, yes.
CO2 is the only thing they know. CO2 and methane is the only thing they know how to talk about, whether it's the United Nations or the New York Times or any report from anywhere. It's all about CO2. It's all about reducing emissions. It's all about, somehow changing human society and human industry, even though human society, like the natural systems, cycle 10 times as much carbon as industry.
Yes.
So industry is like less than 10% of the total carbon being cycled, but we're going to focus on that, and we're going to pretend that we can reduce carbon dioxide with solar and wind, which is dubious in itself. But even if we could, we would only be dealing with a small part of the total carbon being cycled. I read this morning in Matt Power's materials that the fungi of the world, okay, so fossil fuels emit, like, I don't know if it's on a net basis but fossil fuels emit 7 gigatons a year. You can tell me whether that's gross or net, but fungi emit 85 gigatons of carbon dioxide per year. So we got to kill the fungi because they're emitting all this carbon dioxide. We got to go from North Pole to South Pole and all around the equator and kill the fungi because they're emitting 10 times, 10 times as much carbon dioxide as fossil fuels.
Yeah, this is really funny. I can tell you that both of us would be dead if the world was without fungi. So I think that's not a great strategy to go. And it shows again that we're looking at such simplistic ways of looking at the climate and how it really works. That simply doesn't work. If we regenerate the nature, the biology of the planets, this problem will largely go away. I'm not saying we shouldn't lower our emissions, and we will have to do the
Right.
energy transition anyway. And I agree with you that actually solar and wind are not going to be the final solutions, but I mean, they will be a small part of the final solution. Um, and energy needs to be produced for complex interwoven highly technological societies as we have, but now we have to move back into integrating the enormous intelligence of nature and the cooperative systems that are embedded in nature, and understand them and implement them. Our society will not look in any way the way it looks now in 20 years from now. It's up to us whether
Right.
it exists, and then it's going to be completely different, or it simply collapsed.
Mhm. So, one of the things that you say in your book is actually something that I cite frequently, and I was happy to see in your book, Cooling Climate Chaos, a plan to cool the Earth in 20 years. And you said that we've eliminated about half of the biomass on Earth in
Yeah.
the last 5,000 years, according to Vaclav Smil, who did an inventory of biomass. And if that figure is anywhere, let's assume that that figure is valid, that we've lost approximately half the biomass in the last 5,000 years. And that rate at which we're losing biomass continues to accelerate. It's not like,
Yes.
a constant thing over 5,000 years. It's accelerating as
It's
we speak.
accelerating very fast.
Yeah.
Yes.
So it seems obvious to me. I mean, to me, that's job number one, is to replace the biomass we've taken away, to return that which we've stolen. And if we do, if we replace biomass, then there's a somewhat linear relationship between biomass and plant matter, between biomass and plant matter and transpiration, between biomass and the total quantity of water being stored in ecosystems and things like that.
Yes.
So tell me more about this, the biomass, and why is that figure alone significant?
Well, because basically, especially plant life, of course, all green plant life does photosynthesis. Photosynthesis is the process where we all know we take CO2 and water and make it into sugars. Sugars form all living beings, primarily the plants, and then secondary we eat sugars, and then
Mhm.
we animals live off that. But what we especially on land, what we forget is that because of during that process of photosynthesis, which happens as soon as the sun rays touch the leaves, you get this evapotranspiration, and the cloud forming and the rain forming. So basically, the cooling system of the air conditioning system starts as soon as the rays of the sun hit the leaves. If they hit soil that has been degraded or a parking lot, it just heats up the thing.
Mhm.
So removing half of that is obviously not cooling the planet, and is disrupting also all these processes, including the take up of CO2. Um, but also other nutrient processes. There's a lot of nutrient processes that need to be in balance in order to have a good healthy ecosystem, and with that happy inhabitants.
Right. So,
And we can
uh,
put it back pretty fast. Maybe I should also say that if you, uh, I think we're both from the Eco Restoration Alliance, and we can see that there's many techniques and sometimes even just tricks that help the restoration of biomass to regenerate very fast. And we know it on land, and we know it in the sea. And so that's why the 20 years is not outrageous. What is outrageous is that we have to get everybody to do it. But once we do it, this will actually happen.
Talk about the oceans for a minute, because, to me, the number one reason CO2 is a problem is that it's causing the oceans to acidify. But
Yeah.
I think the oceans would have more capacity for, and the reason acidification is a problem is because shellfish need an alkaline environment. The ocean thrives in an alkaline environment, and acidification is a problem. So, but it seems to me like the oceans would have more of a capacity to deal with what we throw at them. I mean, they need more capacity. We degrade them with pollution, we degrade them with overfishing. We've eliminated maybe 90% of the large fishes. Large fishes have the ability to cycle nutrients. We've just really compromised the ocean's ability to process pollution and to deal with trauma.
Exactly. And so if you would be able to restore the biology of the oceans, a lot of good stuff would happen. Um, we've been talking to people who think about ocean fertilization. I don't like the word too much, but basically to give nutrients to areas where there is little phytoplankton. And what you see is that the phytoplankton then comes back very quickly. Now, the first effect is that phytoplankton actually gives off a small a chemical, DMS, which is when released to the air, is actually a cloud condensation nuclei. So it forms clouds and rain. The second thing is phytoplankton gets eaten by zooplankton. Zooplankton actually has a daily migration from the bottom of the sea, sometimes up to a couple of hundred, maybe even 1,000 meters, to the surface, where it comes at night to feed on the phytoplankton. And this migration, which is very few people know about it, is the largest migration in terms of biology worldwide. And that actually, that basically has a lot of positive effect on the vertical water column of the oceans, nutrient-wise, carbon-wise, but also temperature-wise. So if you increase the zooplankton, then you see that the nutrient cycle and the temperature the temperature regulation of oceans improves. So these are just a couple of things. And so Sir David King, who is one of the major climatologists, has said that we may be able to offset as much as 10 gigatons of our CO2 per year by treating the oceans well. Now, oceans are like landscapes and like people, in the sense that you have to customize the reaction to the situation. Because, for instance, in the Gulf of Mexico, you see a lot of dead zones where you have too many nutrients. So there you actually have to have another process of restoring the biology. So in some areas there is a deficiency of nutrients. In other places there's too much of it. But in general, if we heal the oceans, they will draw in a lot of CO2 for sure. Also, then increase the total amount of biology. And of course, I talked about zooplankton, which is, for instance, krill, which of course feeds fish. So you see that the large fish stocks, they will improve, etc., etc. It's an ongoing process of a group of processes that gets better and better at restoring life if we help it. But it means we have to stop all the chemical runoff of our cities and our agriculture, for instance, in order to stop the dead zones. just to mention one problem.
Let me share with you a little bit about why I'm skeptical about ocean fertilization. It seems to me to be a substitute for more fundamental change, like
Okay.
uh, whales have been declined. This, according to my friend Julia Barnes, filmmaker, maker of the movie Sea of Life. But she says whales have declined by 85%. Whales have not recovered from the time when whaling was the thing. And
Absolutely.
if whales were allowed to come back, then they would provide the nutrient cycling that we're looking to happen with the ocean fertilization. And another thing is that, Julia also said that something like 50,000 container ships are on the ocean at any given point in time. The ocean is supposed to be, you would think that the oceans would be the most natural and remote areas of the world, but it's actually an industrial highway with some of the worst pollution in the world because they allow this bunker fuel. And as a result, because there's so much traffic on the oceans, you have boat strikes that are, all this increases over time, because if you increase if the economy grows at 3% of year, 3% per year, then everything else grows with it 3% per year, including the amount of traffic on the oceans. And it just, so those are some of my concerns. And I don't know. Plus, if there comes a time when we have less fossil fuels to use, we have less boat traffic on the oceans, then are we going to have the capacity to sprinkle the iron oxide everywhere and maintain kind of a system that we've created?
No, wait. I think that a lot of these treatments are basically one-off treatments, possibly small repetitions. And I agree completely that the increase of the whale population to the amounts that were there, let's say 150 years ago or so, would have a huge positive effect. But it's part of that total system. Of course, I mean, whales, if we talk about some whales, they eat a lot of krill. So if they and if they die, they take a lot of carbon and they sink it into the ocean. So all these things, they work together. It doesn't really matter from which side you enter into the system to improve it. And I would say do it all at once. And again, it's always context and location specific. Because, for instance, we have Anna Maria Frankic, who is a professor in marine biology, and she has been focusing on restoring oyster beds. Now, we think oyster beds are pretty small things, but they're not. Actually, the oyster beds used to run for thousands of kilometers on places on the Earth, and they would clean up a lot of the water, as we know. So we right now don't have a full view of all these processes that together make up a healthy ocean, and we need all of them, including the whales, including the krill, including the plankton, including the coral reefs. And there's one other thing that I'd like people to understand is that all healthy ecosystems, whether on land or in the sea, actually produce clouds and rain. That is including coral reefs. Coral reefs, when they're really thriving, also give off this DMS, which basically then goes into the air and are condensating water vapor, and it rains on themselves. And it has been proven by studies. They are part of the cooling system. Coral reefs, it doesn't feel natural if you say, but coral reefs, healthy coral reefs, cool. They're part of the total concert of the whole system to keep these conditions for life to thrive happening.
What is the state of our coral reefs?
Probably pretty bad, and there are some positive signs that that recovery of coral reefs um, can go much faster than people thought so far. But otherwise, there are big die-offs. I'm personally not a coral reef
Yeah,
expert, so I don't want to go too deep into that. You should ask Tom Goro. He's probably the #1 expert in the world. He's part of the Eco Restoration Alliance. He could tell you 1,000 things about this. But the state is pretty bad for sure. Yeah.
what is your theory of change? Like we can, excuse me, we could have all the science on our side, we could have all the logic, all the humanitarian considerations on our side, and still not uh, make any change. And if we do make change, it's going to be first one stage and then another stage and then another stage. So what is your theory about how that unfolds?
First of all, I think we don't have enough time to do this sequentially. We have to do a lot of stuff in a very short time in order to avert collapse. At the same time, you can also be positive about collapse in terms of nature. Unlike some other people who talk about Venus syndromes and what have you, I think nature will be just fine and sort of restore the balance on the planet within a lot of it within decades if
I
we.
agree.
If we 95% of us disappear, but that's obviously that's not the mission. The mission is
Not
actually
the
to
outcome we're looking for.
no, we want future generations to have a happy, healthy, a beautiful life on a sustainable planet in a situation of much more equity than we have now, obviously. And that's basically, and our theory of change is basically, yeah, you know, this is the $1 million question. We don't know why humans are continue to behave like this on an ongoing an ongoing way. I quite often say that we're collectively are in a suicidal psychosis, um, because we're acting really really crazy. We're burning down our house and we're threatening each other all the time to kill each other massively. That's a very weird way of a species to behave,
Right.
and I have no answer to that, except that I hope. Um, well, okay, let's first say that people quite often say, uh, the chance that capitalism will be replaced is much smaller than the collapse of the earth. So, first of all, I think that we have to make it profitable, and we have to make a business model for regenerating your planet. I mean, refurbishing houses is a huge business. Why wouldn't cleaning up and making our planet beautiful need not be the largest business on earth? So I think it should be profitable, not crazy profitable, but so that people can make a living. Because right now, basically, the system largely kills it, making profit, and it's NGOs and government policies that basically try to fix it up a bit on handouts.
Mhm.
Obviously, that's not going to work, and I think it's possible with the right kind of story that we can see that investing in a sustainable future could be the smartest investment you could ever make for two reasons, actually. First of all, if we go on like that, our asset base will collapse, which is the basis of all the big fortunes. And secondly, if it gives a return on investment, then you can also really invest and make money there while protecting your asset base. And with asset base, I mean all the buildings that are there, all the infrastructure. And a lot of it is really storytelling, because we all know, for instance, the role of gold in human history. You can't do anything useful with gold. Nothing. It's completely useless.
Right.
But this story has
Yeah.
said, well, if you have that, then you're really something.
Yeah.
So I think we need to change the story.
Right. Well, okay, let's talk about the food system. You say we need to change the food system. So,
Yes.
why is the food system a problem, and what could change, and what would be the outcome of that?
The food system is a problem on many levels. First of all, I would say it kills the soils with chemical fertilizers and pesticides, while the original fertility of soils, which is basically made up of this gazillion of critters working together in producing fertile soils, um, is the basis of all production of food. Um, and once you kill the soil, basically it's just a surface where you can put some plants on, throw in these chemicals, and they grow. But it has so many detrimental effects. First of all, I just told you about the effect that the cooling processes are not working. Secondly, it needs a lot of energy to produce this, while nature does this
Hmm.
free of charge, no questions asked. Um, and um, uh, and also the effects, for instance, the runoff into the oceans basically kills the oceans. So there's so many detrimental effects to all of this. Land use change, it 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 um, dehydrates the land. It kills the soils. It's asking for more and more land to produce these foods. Also, our food chains are ridiculous. I mean, we're cutting the Amazon forest so that soybeans can be grown there, then put them in a ship, put them on the other side of the world, so the Dutch and the Chinese pigs can be grown and then chopped up and then sent over to God knows where. It's complete ludicrousy. We have to have a localized system
Hmm.
where I'm not saying we should do all of it overnight, but a lot of it has to be done in the next 20 years. So a lot of localization of food production. Of course, we all agree much less meat, but that's an obvious one. But I'm not too fundamentalist about it. But at least we should cut down on it, but also not move this stuff from everywhere to everywhere. We simply don't have it adds up to the GDP. So the GDP goes higher, but we're getting poorer of it. I've always understood if two cars crash into each other and the insurance pays out
Hmm. Hmm.
to then basically the GDP grows.
Hmm.
Well, everybody understands the absurdity of that calculation.
Okay, there's a myth that says that if the government were to intervene on behalf of the people, you would have this intolerable degree of complexity. But the problem is not that's the different way to imagine the problem. The problem is more that government is in the business of subsidizing these huge
Yes.
subsidizing, and also public policy gives rise to the World Trade Organization, which is responsible for this. Simon Michaud likes to tell a story of in Scotland they catch salmon and ship it all the way to Vietnam for canning, and then ship it from Vietnam back to Scotland to sell in a supermarket, and that kind of thing. So public policy, the World Trade Organization, if you know how that works, the World Trade Organization exists to eliminate small competition. I mean, that's what
Yes.
they do. And then, um, so you make it marginally more profitable to do this worldwide stuff, and you have more worldwide stuff going on. I heard recently from a reliable source, it's kind of obvious, I guess, that we're getting more and more of our food from other continents. Year over year, there's an increase in the amount of food that we get from other continents. I submit to you that that's not because of free markets. That's just because of subsidizing the big players and then making it so that people in Guatemala or the United States or wherever cannot grow food for themselves. I mean, if you look at bananas, plantations, cotton, what am I trying? Yeah, cotton, bananas, cotton, palm oil, you name it. If it's a big worldwide commodity, then it keeps people from growing food on their own land.
Oh, absolutely. There's no doubt. And so a lot needs to be changed through policy making. But then, of course, we have to have the right kind of politicians, which these days is pretty scarce around the world as well.
Well, we have the best politicians money can buy.
Exactly. Yeah, I think that's a rephrasing of exactly the same that I said. And so one of the things that I really like, all companies, for instance, have to hold to strict accounting principles of their balance sheet, and then report, and then a profit, and then write-offs, and then they have to pay taxes over it and stuff like that. But we all know that the externalities of what we're doing are not on the balance sheet. And
Yeah.
so if we both positive and negatively, if a company is forced to put what we now call externalities, for instance, their emissions, or their water pollution on the balance sheet, and basically that lowers their profit, and that lowers their value. And at the same time, if they would be creating, restoring an ecosystem nearby, that they could put that on their balance sheet, so that their profits would go up. I think with internalizing these externalities, we could get a long way. And the European Union is actually doing this right now with the new regulations. So I guess that will slowly kick in here and there. But again, I don't think that is fast enough.
One way of characterizing that problem is that to say that a forest is worth nothing in our economic system until you cut it down
Yeah.
and turn it into timber, and then you turn it into crop fields for commodities that you grow for export. And those things are worth money. Even the land can be worth money for real estate development, but it's not worth anything in our economic system while it's still a forest.
Exactly. Yeah. And it's crazy. But I think that once we have somehow are able to calculate the eco services of a tree, of a living tree, including the cooling, including the balance of the water cycles, including the protection in a certain sense of weather and stuff like that, then suddenly that tree would start to have value. But then we have to have a completely different calculation system. I can tell you that I'm
Who would
actually.
administer who would administer a calculation system like that?
Well, in a sense, that's already being done, of course. I mean, that's what governments do. I personally don't think that governments in their current form will survive this crisis. So I have no idea exactly what will come after. But in the current form, they are regulating all kinds of policies. I mean, the IRS is pretty top of mind of most Americans. So they somehow got there. So if they would take on these functions of bringing these ecosystem values on board of value systems, I think it's possible. At the same time, I think the most important thing is we have to invent a system where improved land basically becomes worth more. You were just saying, you correctly said, okay, take off, sell the timber, put soybeans on, or bring it into an urban setting, and you tenfold the value in every step of the way of that process. At the same time, we know that a piece of degenerated land, if we somehow bring back the soils to life and the vegetation and its production capacity, that should improve in value as well. But it's not on it's not in this in it. You don't see that awarded in banking systems, for instance. We both know Ed Ewing with his amazing techniques of growing, accelerating biological activity of soils through fungi and bacteria, and you see the productivity of the land can easily 3, 4, 5-fold within a very short period of time. There should be some finance to get that going, no?
I know there's even energy in that. When you have when you
Sure.
add organic matter to the soil, that means energy. And that's
Yeah,
energy
absolutely.
that can thereafter be dedicated to growing food and filtering water, making water clean. It's energy that, well, in its structure, it stores more water. So more water means more plant growth, and plant growth means cooling, and plant growth can mean the biotic pump, which brings rain. They talk about the power, the media sources. New York Times, United Nations are the two that I usually want to draw attention to. They wring their hands about drought, but you can solve drought directly by how you treat the land, and then
Yes.
that would have, these problems have solutions.
Yes.
The media thrives on giving you a problem that either doesn't have a solution or has a fake solution, or they love to specialize in tribalism. If you can get, the people who believe in the science against the people that are the deniers, science deniers, then you've got this cultural war going on, and they thrive on that.
Yes,
But let me ask you,
but we
go
somehow
ahead.
have to bridge that gap because, in bottom line, I think this big polarization, if it comes to wanting to have healthy lands, productive lands, and abundance and beautiful natural settings, I doubt there's very few people who would vote against that
Right. Yeah. If it were on the ballot, yeah.
if it was on the ballot.
Yeah, neither party has a, they don't, neither in the US, neither party has a clue about that. They don't want to have a clue. You've got one party pretending to be the party of environmentalism. Meanwhile, they're just part of the same machine. But I
Hmm.
digress. I wanted to ask you about, you own a valley in the Brazilian rainforest, and you have talked about how fast the recovery has been. Talk about
Yeah.
what you have seen in the recovery of your part of the world.
Yeah, it was pretty simple. So I bought this about 500-acre valley. So it's not enormous, but it's a sizable piece of land, and most of it was meadow, and there were cows on that. And so I decided to bring back the forest. I did that in three ways, by the way. Partly I plowed a part and planted trees. Partly I just let nature go ahead, and partly I help nature by letting it go ahead, but intersperse it with seedlings. And that last one was by far the best solution. That went fast. So it also shows that humans can help nature a bit to recover. But what I think there were three things that were most impressive about the whole thing. One of the first one was that birds came back in such numbers and diversity within years that quite often call it's a refugee camp for birds. Why? Because there's no disturbance, there's no chemical disturbance, there's no noise disturbance. There nobody's wants to kill them or eat them, and so that was just a marvelous gift. The second thing was that we did some special attention because there were 12 sources, springs on the land, and most of them had dried out, and they were just in open land where there was meadow, and so we planted stuff around them, plants around them, and they would come back within years. One of them is actually big enough now that had completely dried up, where year round you can take a little shower under. It's a small waterfall, just enough to take a shower most of the year. So there was the second one. So springs came back.
Mm.
And the last one, I was too lazy to do any measurements of temperature, for instance. But I got several times. I got people coming just from a mile down the road or from the next door, the next valley, say, "It's always so much cooler here."
Mm. Which is our point exactly. It's cooler when you let
Exactly. Yeah.
vegetation come back.
Exactly. Um, and also what I learned simply by just being in that valley every morning. The sun comes up, you see the clouds forming, you see the way the forest reacts to the sun. you learn that it's a marvelous, marvelous system, of beauty, wonder, and efficiency. That once you understand, I said, my God, how the hell did we think we could improve on that? I'm not saying we can't do it at all, but we have to learn much more what's going on there than we do right now. And that's where I also think it's you hear it quite often, but we have to listen to the indigenous people. They do have wisdom and understanding of these systems better than us. Only they quite often say it in a way that doesn't fit our frameworks, so we don't understand immediately what they mean. So to give you a small story, I was walking with a friend of mine, an indigenous chief from the Guajajara Indians, and I was walking through the Amazon rainforest in his area. And the day before, it had been bloody hot, and there was no wind, and there were no clouds. And we woke up, and the next morning, there was a nice layer of clouds, still no wind. And I said, "That's strange. Why are there so many clouds today?" And he pointed out at some trees and said, "Yeah, they want to flower, so they've decided they need some clouds and rain." And
It's
but it was
almost as if they have intelligence, consciousness, and agency.
exactly, and they have, and they do. And what he basically, in our lingo, what he was saying is that if these trees are starting to flower, they throw up a lot of bioaerosols that then condensate the water vapor in the air, and that makes clouds. So there is a perfectly understandable explanation for it from our, but he simply said, no, the trees have decided that they want clouds.
That's a perfect segue to my next. Uh, uh, I have condensation written down. You mentioned condensation briefly, and I like to think, I like to think that vegetation, especially forests, have a key role to play in each of the four elements of the water cycle, at least, evaporation, condensation, cloud formation, precipitation. Forests and vegetation make these things happen. But specifically, how does the condensation happen?
How does the
These
condensation?
the condensation nuclei is really what I'm getting at.
Yeah.
Trees emit condensation nuclei. Some of it's bacteria, some of it might be volatile organic compounds.
Yeah.
So,
Uh,
and
well,
that's an important that's a vital thing to understand in relation to climate.
yes. Well, water vapor is actually the most important greenhouse gas. So when water is in the form of vapor in the atmosphere, it actually captures the sunlight that comes back from the earth in the form of sensible heat, and that increases the temperature of the atmosphere. So, in a sense, you don't want water vapor to stay too long in the atmosphere. Now, if there would be no condensation nuclei, you actually have to have pretty cold circumstances before water vapor in the air condensates to liquid. And if you bring these little particles along, as you said, there's a whole variety of them. If you bring them alongside with the moment that you evaporate that water, um, they are sort of landing platforms for these water molecules to condensate, to go back from the gas to the liquid state much faster. And so you get your water vapor. What you do is first, that water vapor actually was used to carry that energy from liquid to gas, to carry it from the forest floor, the earth's surface, get it up. So you got your heat out, but then you don't want it to stay there too long, because then it heats up as a greenhouse gases. But these condensation nuclei then make it to condensate much faster, um, and then they are cooling again, but now at a higher level. So it's a very
Let's
smart
talk
system.
about let's talk about water as a greenhouse gas. For one thing, if you look at the dominant conversation, the dominant narrative, they almost never even mention that water is a greenhouse gas, even though there are 400 parts per million of CO2 and 40,000 parts per million of water in the atmosphere. So that's one thing. There's a lot more of it. But then some people will say, okay, water is a greenhouse gas. The only reason there's more water in the atmosphere as a greenhouse gas is because first there was CO2, and then there was warming, and then there's more water because a warm atmosphere holds more. But I think what they're missing is what Walter Yenna talks about this, you're talking about this. What they're missing is that if we had more vegetation and therefore more condensation nuclei, then there would be more condensation. As opposed to this water, much of the water in the atmosphere is suspended because there are these like particulate pollution and dust, which tend to it's up there on a semi-permanent basis until such time as you get the condensation nuclei working to bring it back down.
Well, yeah, it's completely true what you say, but it is good to understand that. Okay, we all know that if the atmosphere was completely without CO2 and water vapor, the average temperature of the globe would be around minus 18 centigrade. I don't know what that's in Fahrenheit, but it's very cold. And 90% of the greenhouse gas effect that brings it to 16, 17 plus above zero right now is caused by water vapor. Water vapor is roughly 90% of the warming effect that gets us this nice temperature that we want to have, and CO2 does another 5 or 10 or so. So water vapor is much more important than CO2, and if everything is in balance. But I'll tell you a small story, and I forgot what the source is, and I'm not even sure what it's true. So in the time when Jimmy Carter was president, the story was he was told that we're going to have problems with climate change. And so his scientists come to and they say, well, there's two greenhouse gases. You have water and you have CO2. But water vapor, we can't model. It's too complicated because all the time it's in a different state, and then it's water, and then it's a cloud, and so it warms or it cools. So we can't model that. But CO2 is pretty simple. It's just it's roughly the same everywhere, and we can do the effect. So he said, okay, give me the details about CO2. Never mind about water now, so we understand the CO2. So right. Basically, that the original focus, because the CO2 was simply a matter of modeling.
If you can't model it, it doesn't exist. If you can't model it, we're not going to talk about it. What gets measured gets done. What gets measured gets managed. And if you can't measure it, we're not going to manage it. Okay, so let me respond to that. So the idea is that the water cycles are too complicated to model. But I think the cooling effect of water is not too complicated to model today, because you can get on Google Earth and you can see places that are green and places that are brown. And if it's the Amazon rainforest, it's deep green. And if it's the Sahara Desert, it's light brown. And we can do something. We can plug in some assumptions, and we could figure out, we could have some good working assumptions about what would be the effects if we increase the amount of vegetation. It's like we always have a ratio of vegetation to bare ground.
Absolutely.
When we talk about increasing that ratio, and it's like you said earlier, if we increase the cloud cover by 1.5%, then that would eliminate the greenhouse effect. And what else was I going to say? So how much would it take? How much additional vegetation would be required to make the cloud cover increase by 1.5%? We can at least speculate. We can at least talk about it. We can at least have that conversation. But it's like Milan said, the great thing about, Milan,
yeah, I'm very well aware of his work.
I know you know him, but he was a Spanish climate scientist. And he said, the great thing about CO2, tongue in cheek, is that you can talk about it for decades and not do anything about it. That's the great thing. You could just, talk and talk and talk and talk and talk. And all the time we've been having climate, summits every year at least. nothing. The fossil fuels have not declined one bit, not in any single year, and never because of policy, only because of recessions and COVID and things like that.
Yeah, that's obviously not working. Yeah, and and so, but actually, Peter and I, together with some others, actually, we also wrote a rather technical article on the cooling of vegetation through the water cycle, and we found out that, for instance, the tropical rainforests are the real cooling organs of the planet, the active cooling organs of the planet. They cool a hell of a lot more than grass on the prairies or boreal forest or whatever. And so the cooling capacity was at least 100 times more through the water cycle than through the carbon cycle. And once you understand that, then you want your forest intact if you want to have your planet alive. Um, and so we did a lot of calculation. Again, Peter did the most of the heavy lifting, but I actually also did some calculations, and we came to this conclusion that you can model a lot of the aspects, and probably with the smarter models, both the satellite observations and the possibility of AI cracking a huge amount of data, we are probably able to more and more start to model this locally, because it's different everywhere. Unlike CO2, every situation is different. Every moment of the day is different. And but the aggregate effect we can calculate. And of course, if you have more vegetation, or you have a more lively ocean, you will also increase your cloud your cloud cover. But it's not the only thing. It's all of the things above that I mentioned. So first, evapotranspiration is one. Then um, so the cloud forming is one, but also the radiation out into space is one. The creation of wind that basically dries humidity inland, that gives more precipitation inland, so that the process can cool there too, are all part of the whole deal.
Let's talk about that re-radiation, because I think that's now I think that's an important part of it. So when I first learned that evaporating water has a cooling effect, it's like, okay, water evaporates, but then it condenses. So if evaporating water has a cooling effect, then condensing water would seem to have a warming effect. And
Yeah,
for one, so why isn't that just, what goes up must come down? Have we gained anything from this water cycle? I have two responses to that. One is it matters where the heat is. It
exactly.
matters if you have, so that's one thing. And it matters what the sun shines on. Is it shining on bare dirt and creating heat, or is it shining on plants and has this air conditioning effect? But
Exactly.
also the condensation that causes the radiation of infrared back out into space, that is a mechanism for moving heat out of the biosphere and away from. We have a mechanism for incoming heat. It's called sunshine, and then that's a form of radiation. We need a mechanism for either processing that heat here to turn it into something that is not sensible heat, which is photosynthesis and
It's
things like that.
photosynthesis.
But
Yeah,
also a certain amount of heat goes back out, and it's because condensation occurs. When condensation occurs, that results in a certain amount of sensible heat and a certain amount of radiation, much of which is infrared. It's going in all directions. Some of it is going out into space. So can
yes.
we talk about having that as a mechanism for reducing the amount of heat in the atmosphere?
Yes, we can. It's a matter of increasing the amount of vegetation, and specifically forest, and even better, tropical rainforest, because there the effect is most. Because not all ecosystems do the same thing in the same amounts. But yes, that's exactly how you cool your planet. I mean, if we're saying we proposal to do this in 20 years, we have very specific reasons to say that we actually calculated if you can revegetate 280 million hectares, mind you, that's roughly a quarter of the United States, um, in the tropical zone. and anywhere where there is degraded land, or open agriculture, monoculture, seasonal cropping, and you bring back forest or agroforestry forms on that, that increase this evapotranspiration cycle, the total cooling effect will be 1 degree centigrade on a global scale. Well, that is something I would love some scientists to go through, crack the numbers that we gave and say, well, you're bonkers, or say, there might be something there.
Well, the powers that be keep the conversation where it is by not responding to such things, in my view.
Exactly. It's crazy. I mean, at least, you know, I'm coming out of nowhere, but Peter has been working on this stuff, and I worked with guys like James Lovelock, who is not uh, the first scientist, and you simply get neglected. The difficulty to publish this book is just crazy. Um, I've no idea why it all gets so complicated, but it's like, it's not even that nobody's interested. I have a feeling they don't want it.
Right. So, if I like to say a couple of things. People who are wringing their hands and crying and screaming about CO2, do they have a plan for drawing down CO2? And I say there's a combination of there's a combination of corruption and ineptitude there. But if you cared about CO2, you would stop subsidizing nitrogen fertilizers. You would stop subsidizing chemical fertilizers, for one thing. You would, if you cared about CO2, you would end crop insurance. Phase it out over 5 years. I don't care. But we need to see an end to crop insurance, because in the US, because crop insurance has the effect, it encourages monocultures, it encourages toxic pesticides. That's another form of subsidy. When you use neonicotinoids and you're killing insects as a result of that, that's a shift in wealth from the people who might otherwise like to have insects to the people who make money selling insecticides. So I don't think the conversation about CO2 is a serious conversation, because the people who are having that conversation don't even have a serious plan for dealing with CO2, because you would have to oppose industry. And they make it sound like if you just bring about solar and wind, you can draw down CO2 without changing agriculture, without changing transportation, without changing overhunting and overfishing and all that. So.
Yeah, it's true. I mean, it's a ridiculous story, and I mean, I'm also amazed that tens of thousands of scientists sort of buy into this game, while anybody who looks from outside in a few minutes says, "What the hell is going on?"
Well, if I read the papers, if I don't read the papers, I'm uninformed. If I read the papers, I'm misinformed.
Mm-hmm.
So you have the people who read, and nothing against people who read the New York Times per se, and I know people who read the New York Times who also understand what you and I are talking about. But and I read the New York Times because I have to. But anybody who thinks you're getting the truth ought to go back and read Noam Chomsky's Manufacturing Consent, and see how systematic the deception is. When they want to lie, they lie systematically and with credibility. And so there's that.
Yeah, mind you, I have been reading the New York Times for decades, and I do it every day also. And I do think that we shouldn't exaggerate the amount of malice that's in there. It's just people repeating the same songs within the system and not getting criticized for the nonsense that they're blaring out.
It's
And
not malice, it's careerism. It's I know who signs my paycheck, and I can smell what they do and don't want me to report on
yeah, so there's very little malice. There is some malice, but it's a very small part. But it can be very destructive. But the most of it is just people are not prepared or not able to look outside of the box and see that there's actually a whole different way you can look at the reality.
Well, what is advertising? What is sponsorship? If I'm sponsoring if I pay for advertisements in major media, what I'm buying is the right for them. I'm not selling, sometimes I'm selling product, sometimes not. Even if I'm, they don't advertise Boeing because people are buying airplanes. They're buying the right for big companies to not be investigated with any vigor or any consistency. You're buying off the mechanisms for investigative reporting. Let's end on a cheerful note.
Yes, let's do that because we're not here just to waste our time. We have to find a solution to the whole
Well,
bloody
one
mess.
thing, okay, here's something cheerful. I teach what I teach partly because it does give people agency. If you own and control and manage an eighth of an acre, then you have something that you can do. You can restore the soil, you can restore the ecosystems, but anybody, anywhere, especially communities, can reestablish vegetation and bring back wildlife, which has an effect, a positive effect. It's the only thing, in a sense, the case could be made that it's the only thing that really matters is the thriving ecosystems, complete with the vegetation that it takes to support them. So that
Yeah,
gives us something we can do here and now,
yeah,
even if the big institutions never change.
exactly. Yeah. So the solution to cooling the climate, um, cooling the planet, is actually that it gives everybody agency to do something where they are, and that democratize it makes them more powerful. I think a lot of the problem why people are denying the severity of the crisis is because they can't see a solution. So why the hell would they bother thinking about something they can't solve in the first place anyway? And you might as well just go on your merry way and see where it all ends. While if you get the agency and you see the total picture that if we do all of us, we can get us out of the trouble within 2 decades. I think you get a totally different energy of the climate movement and the youth saying, "I want my planet back."
Right. If they would direct their energy into something that works, that would be great.
Yeah. Okay. So, so my question to you is, okay, suppose we do everything right and it's 2040 and things look up and the biology of the planet is reviving and the temperatures stop rising and the weather is getting less chaotic and societies are getting more calm and positive and happy. What did we do between then and now that made that switch, that awareness somehow took over and basically formed what is basically a global movement for regeneration?
You're asking me. I'd love to respond, but do you have an answer, or do you want me to answer?
No, I want you to answer. I would like
Okay,
to
so I
hear you.
have two. I have two answers to that. I've heard it said, like John Kemp and Matt Powers have both said this recently, and it says, "Don't tell people what to do. Help them understand how things work."
Yeah,
Because what to do might change when the circumstances change, but if you understand how things work, then they can make adjustments as they see fit. And I would just what I want people to understand two things. One is I want them to understand how the living world works, including the soil, including the forests, including the climate. I want them to know how that, including, food, food grown, healthy food. I would want them to know how that works. So the natural world and healthy food, I'd want them to understand that. And then I would also want them to understand how power works, because we don't.
No, we don't.
We're being blindsided. It's like we're walking around with blindfolds on, thinking our vision is 2020. We don't understand. We can't see the world around us. We don't understand how things work. And in that regard, and I would want people to understand the media first and foremost. And I would recommend Noam Chomsky's Manufacturing Consent. And I want people to read Hate Incorporated, Hate Inc. by Matt Taibbi. Those are the two books that I know of that really tell you how the media works. And I'd want people to know how government really works, because Poseywood is Stafford Beer, British business professor, said Poseywood, purpose is an acronym. The purpose of a system is what it does. If you want to know the purpose of a system, don't look at the rhetoric. Don't look at what they want.
Look what it does.
Look at what it does. And if you look at the purpose of our system, the purpose of government is to throw money at rich people. I mean, because that's what it does. That's what happened in COVID. That's what happens with the military industrial complex. The purpose of the media. I like this quote from Henry Adams. So if I may, Henry Adams was the great grandson of John Adams, the grandson of John Quincy Adams, the second and sixth presidents of the United States. His father was Charles Francis Adams, who was ambassador to the United Kingdom in the Abraham Lincoln administration. And so here comes Henry Adams. He lives from like 1838 to 1918. He lived 80 years. He wrote a 7 or 9 volume history of the Jefferson and Adams administrations, which was acclaimed for its literary style and its command of the documentary evidence. So Henry Adams, not a lightweight and not a flower child, he said the press is the hired agent of a moneyed system and set up for no other purpose than to tell lies where their interests are involved. One should trust nobody and nothing. Now, you can believe that or not believe that. That's how I see it, because I see how the deception and the mendacity is large scale and very systematic and very consistent over time. Media, the media changes, internet comes along, but the role and the purpose of media doesn't change. And so we need to understand how media works, and we need to understand how government works, and we need to understand how the living world works. And because for the time being, I cannot change media or government, I choose to educate people on how the living world works. And I'm a student of Matt Powers, and I'm a student of Elaine Ingham indirectly. And also, I really recommend Jeff Lowenfeld's books, Alaska lawyer who wrote 4 books about soil biology, teeming with microbes, teeming with nutrients, teeming with bacteria, which is about the rhizophagy cycle, and teeming with fungi, which is all about primarily mycorrhizal fungi, which, if you understand how those things work, then you've got efficient cycling of nutrients, you've got efficient use of water, you've got soil that's growing in its capacity to grow plants and its capacity to absorb and hold on to water and grow good food, grow nutritious food. The only thing that, I know I'm going on and on about this, but the only thing that's capable of growing nutritious food is healthy soil. That's the only thing that's capable of delivering nutrients to the plants. So
yeah, it is that simple. And I must also say that I think we sided with the winner, because I'm with you there.
Right.
Because governments will come and go, and this system that we have now will simply disappear, but the fungi will reign for many millions of years.
Absolutely. That's a great place to end. It has been my pleasure to have robdelaet, co-author with Peter Bunyard, of Cooling Climate Chaos, a proposal to cool the planet within 20 years. Rob, thank you so much for joining me. Is there any parting words, or how can people get in touch with you?
Well, thank you for your time and listening to this story. Yep, I'm sure you'll probably put my email somewhere, so let them just say hello. If it's true what we're saying, this is the most optimist story that I think is available to get us out of the mess we're in. And it has all kinds of beautiful by effects because it improves the food system. It improves food and water security. It improves poverty. It eradicates poverty to a large extent in the global south, especially rural poverty, because money will stream back into those lands while they are regenerating. So there's very little that can go wrong with the plan. So I'd love people to support it, basically, because I think we've been working for years at this solution set, and I think it's really, really an important solution set. So I hope it gets the traction it needs.
I think it will. Our guest has been Rob His email is robdelaet@yahoo.com. Thank you so much for joining me, Rob.
Thank you so much, Hart. Thank you so much.
My pleasure.